Okay, now we're going to start the examples for 10.2. And the great thing about video is that you can stop and start whenever you want to. Just so you know, I have the answers in front of me, and I hope they're all correct, but I won't guarantee. I tell my students my first day of class that I cannot add, subtract, multiply, and divide. Those are the things, or spell. Those are the things I make the most mistakes on. I have also found this semester I have a hard time reading in class. So, hey, such it goes. Part number 14, and this has different parts to it, and so I worked through several of these parts. We're going to find the area for each of these figures and the perimeter. So make sure, I've had students on tests that haven't read the questions. Make sure that you're answering both pieces. I've had students that have only given me the area when it's asking for both. Let's start with the perimeter. The perimeter is simply going to be A plus B plus C. So that's going to be 17 millimeters plus 22 millimeters plus 32 millimeters, which will give us a total of 71 millimeters. Now, you will notice that I write the units every time, every place I use them. And the reason is, by writing the units every time, I don't forget to put them in the answer. The area, this shape is a triangle, so the area of a triangle is 1/2 base times height. So it's going to be 1/2. Our base is C, so that's C, and our height is D. So we're going to have 1/2 times 32 millimeters times 11 millimeters, which gives us an area of 16 times 11 is 176 millimeters squared. I have millimeters times millimeters, that's millimeters squared. So our area is 176 times millimeters squared. Now, for the obtuse triangle, we have the perimeter of E plus D plus B. Notice that I did not add this piece. It is the perimeter is strictly the part around the triangle. So it is going to be E, D, and B. Okay, that is what my perimeter is going to be. So that gives me E is 13 millimeters plus D is 29 millimeters and B is 36 millimeters, which gives me a perimeter of 78 millimeters. The area of a triangle is 1/2 base times height. So the area is going to be 1/2. Our base is D. So that is our base. And our height is A. So that's going to be DA. So that's 1/2, 12 millimeters, and D is 29 millimeters. Does it matter that I put A in first? What is 2 times 3? 6. What is 3 times 2? 6. So it does not matter. So our area then is 174 millimeters squared. Okay? Next, we have an equilateral triangle with 2 centimeters. So if we have an equilateral triangle, then we have to find the height. So if the whole thing is 2 centimeters, the height is a perpendicular bisector. So that makes this 1 centimeter. So if this is 1 centimeter, if this piece is 1 centimeter, and I know that this is 2 centimeters, how do I find the height? I'm going to use Pythagorean theorem. But first we need to find the perimeter. The perimeter is going to be 3 times A, because I have 3 sides of a triangle. All sides are the same. So that's 3 times 2 centimeters, which gives me a perimeter of 6 centimeters. Yikes. Area. For the area of a triangle is 1/2 the base times the height. I need to find the height. So the height you're going to find by using h squared plus the 1 centimeter squared has to equal the 2 centimeter squared. So that is h squared equals plus 1 centimeter squared equals 2 centimeters squared. So h equals 1 centimeter squared. Did I do that right? No, 2 centimeters is 4. Hello. Told you, can't add, subtract, multiply, or divide. So h equals the square root of 3 centimeters. Okay? So then my area is going to be 1/2. My base is 2 centimeters. And my height is the square root of 3 centimeters. So my area equals, these two cancel, it's the square root of 3 centimeters squared. And that, to me, is a perfectly good answer. WebAssign may want you to put that into your calculator and come up with a decimal. Okay. A circle, assume that the diameter is 12. So we remember that the circle's perimeter is called the circumference, and it's 2 pi r. Well, if my diameter is 12, if d equals 12 centimeters, then what is my radius? It's half of d. So it is 6 centimeters. So my circumference is going to be 2 pi times 6 centimeters, which gives me 12 pi centimeters. That is a perfectly good answer to me, but WebAssign again will want you to use 3.14 to get the decimal answer. And I hope all of you know how to do that. I will show you on your calculator. You're going to have 12 times, and you're going to use the second key, pi, which gives you a bigger number, or you can do 12 times 3.14, and you get 37.68 centimeters. Okay, now on your exams, I just as soon have 12 pi centimeters. Our area for a circle is pi r squared. We all know that pi's are squared, don't we? So our area is pi times 6 centimeters squared. So that's 36 pi centimeters squared. And again, for me, that is a perfectly good answer. WebAssign will want you to put that into your calculator and come up with a decimal. But decimals are rounding, and I don't like them. Okay, here is a parallelogram. So we know that this, to find our circumference, we're going to have our perimeter. We have A, B, A, B. So our perimeter is 2A plus 2B. So that's 2 times 8 centimeters plus 2 times 12 centimeters, which is 16 centimeters, plus 24 centimeters, which is 40 centimeters, is our perimeter. The area of a parallelogram is base times height. So that is going to be, our base is B times A. I'm sorry, B times C, which is going to be 12 centimeters times 6 centimeters, which is 72 centimeters squared, which is wrong on the key. On the key, I said area of a triangle, so I need to make sure I go back and fix that. Okay? I'm making a note to myself. Chapter key part E on example. Okay. Sorry, needed to do that. Perimeter is going to be A plus B plus C plus D. So that's going to be, oh, you can't see me? Ha ha ha. Perimeter of a trapezoid, A plus B plus D plus C. Now notice this is a trapezoid that is not isosceles and it's not a right trapezoid. So if you were going to try to derive the formula, you would have a little bit more work cut out for you, because you would have to cut this piece off, you turn it over here, you turn it sideways, and you cut the tip of this off and you turn it sideways to make your rectangle. So it's a little more difficult to do it, but it is doable. So A plus B plus C plus D is our perimeter, so that's 5.5 centimeters plus 6.4 centimeters plus 8.2 centimeters plus 15.7 centimeters gives us an area of, gives us a perimeter of 35.8 centimeters, and I'm assuming that's right. Check, do the add them up, make sure if you would like. Let me know if you come up with a different answer. The area of a trap is 1/2 the height times B1 plus B2. So for this particular half, that's going to be 1/2 E times B plus D. So that's 1/2 4.7 centimeters times B is 6.4 centimeters plus D is 17.5 centimeters. Plugging this all in, coming out with an answer, what we come up with is that the area is 50.76 centimeters squared. Okay, so that is the end of that one question. Now we're going to talk about question number 2A. And so what we're going to do now is we're going to put different objects together. And so here we're going to make a snow cone, but this would really be the cross-section area. So if you sliced it down the middle, what shape would you have? And we have a semicircle, and we have an isosceles triangle. Okay, and we want to find the area and the perimeter. So again, I'm going to do area in pink, and perimeter is in yellow. So to find the perimeter, we're going to have to find half of the circumference, and then we're going to have to find the length of these two triangles, of the sides. All we're given is that it's 6 meters across, so that means my radius is 3 meters, right? And this is 6 meters. So in order to find this piece, I'm going to call that B. In order to find B, I'm going to have to use the Pythagorean theorem. So B squared equals 6 meters squared plus 3 meters squared. So that's 36 meters squared plus 9 meters squared equals 45 meters squared. So B equals the square root of 45 meters, which is 3 square roots of 5 meters. Now, to find this distance, that is going to be half of the circumference. Well, the circumference, it's going to be 1/2 2 pi r, so it's just going to be pi r. Okay, and let's call that distance d. So d is going to be pi r, so that's pi, and our radius is 3 meters. So that distance is 3 pi meters. So our perimeter is going to be b, 2b, plus d. So that's 2 times 3 square roots of 5 meters plus 3 pi meters, which gives us, putting it into our calculator, what we come up with is 32.26 meters. And somehow I changed my answers to centimeters without changing units. So that is our perimeter. Okay. Now we need to find the area. The area of a circle is pi r squared. I'm going to check that answer. 2 times 3 times the square root of 5 plus 3 times 3.14. Arg. Square root of 5 plus 3 times 3.14 equals, who? Totally different answer. Okay, so this answer should be 22.83, not 32.26. Got to thinking that must be wrong if I'm making a mistake somewhere. The area of the circle is going to be pi r squared, so we're talking about half a circle. So our area is going to be 1/2 pi r squared, plus the area of a triangle is 1/2 base times height. So that's 1/2 a times a, because our height is a, which gives us 1/2 times 3.14 times our radius is 3 meters squared plus 1/2 times 6 meters squared. So our area equals 32.13 meters squared. So I wonder if I looked at the wrong answer. Nope, I didn't. Okay. So there is that, and this is the correct answer for part A. Sorry guys. You may want to check your answers on this. I'm just copying them down without actually working them. So the answer above is correct. But the second answer I'm not getting the same. So I got a different answer for this one. I got 56.165 for that. Yep. So this answer should be different. Sorry about that. Teachers not perfect. Okay, now I call this our little alien walking person, however you want to do it. The way, now let me say this. Students struggle a lot with this question, with how to break it up. You will see this. If you are taking my course, you will see a figure on dot paper that you have to break up and come up with an area for. Because they do this in elementary school. This is 3rd, 4th grade math. Okay, is being able to break this up. It's the same thing that you have to be able to see this snow cone and see that it's a semicircle and an equilateral triangle. Or not equilateral, but an isosceles triangle. So you need to be able to break this up. So what I'm going to do is I'm going to draw a line here. And I'm going to draw another line here. And I'm going to draw vertical lines right there. And all I'm doing is I'm trying to break this into shapes that I know how to find the area of. This is a trapezoid, correct? But in order to find the area of this trapezoid, I'm going to have to find these hypotenuse. So what I do is I break them into triangles so that I'm not having to find, I'm not having to use a quadratic formula. Okay? I want to break it into shapes. It doesn't matter how many shapes I have, right? It just matters that they're shapes that I can find the area of easily. I also, I will do this one as though it is a trapezoid. Okay? So, how do I do this? I call these different regions. This is A. Let's call this B. Actually, I called this B. Let's call this C. This is D. So I have D and D here. And I have 6 C's. There are a total of 6 part C's. Call this part E. And this trapezoid, that's the feet, part F. And then I find the area of each individual piece. So the area of A is length times width, which is going to be, and then I also like to go in and I write in here, this is 2, this is 2. This is 1, 2, 3, 4 by 1. This is 1 by 1. This is 2 by 1. 1, 2 by 1, 2, 3. This base is 2. This base is 1, 2, 3, 4, 5, 6. And this height is 2. So now I have all my units in there. So the area of A is length times width. So that's going to be 2 times 2. So that's 4. The area of B is a rectangle. It's length times width. So that's 4 times 1 is 4. The area of C is a triangle. So that's 1/2 base times height. So that's 1/2, 1 times 1. So that's 1/2. But then remember I have 4 of those. So that's 4 times C. So that's 4 times 1/2. So that's 2. And that's the area of all the C's. So this is all C's. The area of D is length times width. So that's 1 times 2, which is 2. I have 2 of those. So I have 2 area of D's. So that's 2 times 2 is 4. And so that's what I'm going to use in the end. Okay? Actually, we can do it without doing that. We'll do that later. Make it easier. The area of E is length times width. So that's 2 times 3 is 6. The area of F is 1/2 H B1 plus B2. Right? Which is 1/2 times 2 times 2 plus 6. Those two go away. 2 plus 6 is 8. So that area is 8. So my total area is A, area of A, plus the area of B, plus 4 times the area of C, plus 2 times the area of D, plus the area of E, plus the area of F. So my total area is going to be 4 plus 4 plus 4 times 1/2 plus 2 times 2 plus 6 plus 8. So my total area, this right here is 2, this right here is 4. 4 times 3 is 12, 13, 14. 14 plus 6 is 20, so my total area is 28. Oops. Oh, I don't have 4 of those. How many of those do I have? I have 6. So that should be 3. So this should be 29 square units. All right, because there's 6 of those. So it shouldn't be 4 here. It should be 6. Okay? Make sure you put the square units. Otherwise, you will miss it. Since I've done all the areas in pink, I will keep doing that. So there is my pink. And that concludes that example. All right. I'm just kind of looking. I'm going to pull off. I'm pulling off the back of the notes so that I can know where to stop. Okay. Determine the arc length of the circle. If the diameter, so the diameter is 10 centimeters and the angle is 130 degrees. All right? So I want to know how much this arc is. Well, how do you figure that out? How do you think about this? What is the percent? Let me ask it this way. What is the percent of the circle that is taken up in this dark region? What is the percent? How do I figure that out? Well, how many degrees is an entire circle? 360 degrees. So this piece right here that's colored in is 130 over 360. So the area is going to be 130 degrees over 360 times, that's the percentage of the circle, times pi r squared. Well, what is r? Half of the diameter. So this is going to be 130 degrees over 360 degrees times pi, which they want us to use 3.14, and our radius is 5 centimeters squared. So how do we figure that out? Nice handy calculator. So I have 130 divided by 360 times 3.14 times 5 times 5 is 25 equals, so our area is 28.34. Round your answer to 1 decimal. So 28.3 centimeters squared. Okay? So that's the area, but it wasn't asking for area. Woohoo! That's area. It wants arc length. So what am I going to do for arc length? It's not going to be the arc length, is not going to be the area that I use. Sorry about that. It's going to be the same thing, but I'm not going to use pi r squared. What am I going to use? 2 pi r. So our arc length is going to be 130 divided by 360 times 2 times 3.14 times 5 equals 11.3 centimeters, because they want 1 decimal place. I say centimeters, it says feet. Okay. Sorry about this. I feel like I'm doing a very bad job on this section, but I hope you're following my mistakes. How do I determine the area of the figure below? I'm going to break this again into things that I can find the area of. So I'm going to continue this line up so that this is now B, and then this piece is C. So this side right here is going to be B minus C. Right? If the whole side is B, then the whole side is going to be B. Right? If I draw a vertical line there, this is B, that's B. This piece is B minus C. That's where I'm looking for it. And that's C. A is the whole side, so this is C. This is B, so this right here is going to be A minus B plus C, is that little piece right there. Okay? So if I call this 1, this 2, and this 3, then the area of 1 equals, it's a rectangle, length times width, so it's going to be BC, which is going to be 12 centimeters times 6 centimeters. So that is 72 centimeters squared. Area of 2 is going to be, again, it's length times width. Length times width. So it's going to be B minus C, because that's this piece, times A minus B plus C, which equals A is 24, so this is going to be 6 centimeters times 6 centimeters, which is 36 centimeters squared. And all I did was went down here and found each of those individual distances. It's found each of those individual distances to find out that area. So then the area of region 3 is going to be B times B, because again, we're length times width. So that is going to be 12 centimeters times 12 centimeters, which equals 144 centimeters squared. So our total area is going to be area of 1 plus area of 2 plus area of 3, which equals 72 plus 36 plus 144 centimeters squared. So we get 72 plus 36 plus 144 gives us a total of 252 centimeters squared. And that is our total area of the shaded region. Okay? The trick to any of these is to break it down into the shapes you know, and then find each little piece. So I try to always break it into rectangles. Rectangles are my friend. I can find the area of a rectangle. Okay? Let's say that we have a square whose side measure 11 inches. Determine to 2 decimal places the dimension of the square that has twice the area of this square. So if I have a square where each side is 11 inches. So I have 11 inches by 11 inches. Okay, well then the area of the square, the area is length times width. So this area is going to be 11 inches times 11 inches, which gives me 121 inches squared. And I want to double it. So I want to double the area. So that's 2 times 121 inches squared, which gives me 242 inches squared. Now, again, I have a square. The area of a square is side squared, length times width, but each length is the same, so s squared. And that has to equal 242 inches squared. So I take the square root of both sides, so I get that s equals the square root of 242 inches. And that is, so s equals 15.56 inches. So the dimensions of the new square are 15.56 inches by 15.56 inches. And the reason I put both measurements there is we typically measure stuff. We typically say that it is by this distance, by this distance. So even when you say a 2x4, what you're talking about is a piece of board that is 2 inches by 4 inches or 2 feet by 4 feet. So you use those measurements. So how many square inches are in 1 square foot? So if I have 1 foot squared over 1 and I want to change that to inches, so 1 foot equals 12 inches, and I do it twice, so that's 12 inches is 1 foot. That gets rid of feet squared. And so that tells me 12 times 12 is 144 inches squared. Okay? Now, we're getting into some fun stuff here. And you're thinking, I don't think so. I don't think so. 1 bag of mulch. 1 bag of mulch bark is 20 feet square, will cover 20 feet square inches. If landscaping architect wants to have a border of plants around the sides of a 6-foot shed by 12 foot, and this should be 6-foot shed by 12 foot, so sorry, the by 12 foot, 6 by 12 foot shed, how wide can the border be? Round your answer to 2 decimal places. So this is 12 feet, this is 6 feet. And I'm going to add X inches to all these sides because my border is uniform, okay? So how do I do that? I know it's given me this stuff. It's giving me all this information in the area. So I need to figure out the area of this little border region that's all the way around the shed. Okay, so how do I do that? What I'm going to do is I'm going to find the area of the shed, I'm going to find the total area, and I'm going to subtract the area of the shed from that, and that's going to give me just the area of the border. Okay, so I need to find the area of the big rectangle minus the area of the shed, and that will give me the area of the border. Okay, so if I add X to each of these, that means that this is the outside length is going to be 12 plus 2x, and that this outside width is going to be 6 plus 2x. So that means the area of the outside is going to be length times width, which is going to be 12 plus 2x times 6 plus 2x. All right? And the area of the shed is going to be length times width, which is going to be 6 times 12. All right? And so where do I go next? I stopped looking at the wrong question. Sorry, I'm pausing. I'm looking at the wrong question on my... I was looking at the question for this, and I'm like, we don't ever talk about money in this question. I know that I only want to use 1 bag of mulch. And I know that this border area, so that means that the area of the outside minus the area of the shed has to equal 20 feet squared, because I only want to use 1 bag of mulch. I don't want to have to spend a lot of money, and I just want enough to go around, just a thin amount. So these two areas have to equal 20 square inches. So how do I do that? Well, that's going to be 12 plus 2x times 6 plus 2x minus 6 times 12 has to equal 20. FOIL that out or multiply it all out, and I get 72 plus 2 times 6 is 12. 2 times 12 is 24. 12 plus 24 is 36. 36x plus 4x squared minus 72 has to equal 20. So I have 4x squared plus 36x. Those two go away. Minus 20 has to equal 0. That is a quadratic. I now have to use the quadratic formula. So remember, the quadratic formula is that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I hear groans and I hear, oh my gosh, I'm going to teach elementary school. I don't have to know this. Okay, let me say this real quickly. Do you only want to know the knowledge that you're going to be teaching? I hope your answer is no. I don't care if you're going to specialize in whether or not you're going to specialize in math. Pythagorean theorem is taught in 7th grade. I know there's a popular TV show, I don't know if it's still on or not, that used to be, Are You Smarter Than a 5th Grader? Do you want to have the ability to be able to graduate high school even at 30 years of age? I hope that all of you say yes. You're going to be teachers. I hope you're striving for knowledge and wanting to learn. Yes, you need to know this. There are some basics. If you don't want me to know how to spell pride or how to spell the, then why should I expect you to be able to add or multiply? And you may say, well, this is harder than that. Yes, it is. But so is spelling supercalifragilisticexpialidocious. Doesn't mean I can spell it because I can't spell. But so is spelling things like mathematical or science or biology. They're not all easy things to do. There is a base knowledge that every person should have. Okay. Other than that, another way to say it is suck it up and deal with it. Yes, you have to solve this by quadratic formula. Is this typically a question that is asked on the test? Only if it's factorable, which it could be. You could have it on the test and it be factorable. But I'm just saying that this would be something that would be given as a bonus. But, you don't need to know that. You still need to be able to work these. By using the quadratic formula, putting in the numbers, putting it in my calculator, I come up with, I get x as 0.6394 and negative 15.6391. Well, I know that I can't have a negative distance, so I can knock that one out. That tells me that x is this. So the width of the border should be 0.64 feet. Okay, would I get a yardstick out and measure it to be that distance? No. Would I eyeball it? Yes. If I were doing this for my house. Actually, probably me, I would buy another bag of mulch. So, but I can understand that money is tight. You don't always have the money to do that. Bernice wants to seed her large backyard with grass. Her backyard is the shape of a rectangle. So we have a rectangle. And it's 80 feet by 140 feet. All right. The seed costs $4 per pound, so $4.99 per pound. Each bag, and so this covers 1,550 square feet. How much will the seed cost? Well, you have to find the area of the backyard. So we need the area of the backyard, which is length times width. So that's going to be 80 times 140, which is going to give me an area of 11 feet, that many feet squared. So now I need to find how many, so if that's my area, this covers this many, so I need to find out how many times this number goes into that number. So I want 1050 divided into 11, and what I get is I get 10.66, the repeating decimal. So that's 10.66 bags are what I need. So this tells me how many bags I need to cover the backyard. So I need 11 bags, right? Because if I get 10, then I'm not going to finish it. I'm not going to be able to cover it all. Times $4.99 a bag, right? So that is $54.89. The seed will cost $54.89. Do you notice that I'm writing all my sentences in complete answer? Should you write all your answers in a complete sentence? I'm writing all my answers in a complete answer. Yeah, all my answers should be written in a complete sentence. Now, all right. Everybody good? Everybody good so far? How we're going to do the next question is, the way that I do this is, remember, I've said all along, I am a quilter. That means I quilt. I sew. I make blocks that look like this thing. And what you do is you break them up into their pieces. Quilting is all about geometry. So I want to break this thing up into its pieces. And that's what I'm doing right now, is I'm just breaking this sucker into all its little pieces. I sew a good bit. I make quilts. This year in 2013, I am trying to make 12 quilts. I've made about 8. I don't think I'm going to make I don't think I'm going to get all 12 made, but I've tried. I know I'm not going to get them all quilted. I do half of my quilting is piecing, is by hand, and the other half is machine. All right, so now I have it broken into all my pieces, and what I'm going to do is I'm going to count. I want to know the area that the dark blue takes up. Okay, I count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is a total of 36 squares, right? And so what I'm going to do now is I'm going to count how many dark squares. Okay, I have 1, 2, 3, 4. So I have 4 that are dark squares. Now I'm going to count the half triangles, so the half squares. Okay, that's what we call them in quilting, is we call them half squares. And that's the triangles that take up half a square, like this right here. And I'm going to count those. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I have 24 half squares. Well, they're half squares, so that means that 2 of them together make a square. So this 24 half square gives 12 squares. Does everybody understand that? 24 half squares give me 12 squares. So I have then, if I add those 12 squares plus to the 4 squares, I have 16 squares over 36 squares. So 16 are dark over total. So 16 over 36 is 0.44. So then 44.4% of the block is dark blue. Is dark. Actually blue if you look at it in color. Alright. Now, I am omitting I'm trying to look because I omitted some of these. So maybe my answers are correct on the thing. So I am going to do, all of these are correct. I'm omitting ones off of my key. So that means my key is not correct in the file that I printed. Okay. So let's look at, I have 2 more pages. Woohoo! Let's look at this one. Make 2 rectangles that have the same area but different perimeters. Let L1 be and W1 be the length and width of the first rectangle. Let L2 and W2 be the length of the second rectangle. Enter your answer as L1, L2. In other words, I want 2 pair of numbers whose product is the same. So I want L1 times W1 to equal L2 times W2, but I want them to be different numbers. So, well, one of the obvious one is to do 2 by 3 and 3 by 2, right? But those are actually the same rectangles, they're just rotated. What if I did 4 and 6? So what if I let one rectangle be 3 by 4 and the other rectangle be 2 by 6? Wouldn't that be the same thing? So I have 3 times 4 is 12, 2 times 6 is 12. Okay, so there's an example of that. Another in the notes, I use 24. 24 is really good because what you're looking for is you want the area to be something that has a huge number, 24, 42, that has a lot of factors. Now, the Superdome, New Orleans Superdome has a diameter of 680 feet. 680 feet. What is the circumference of the Superdome? So the circumference is 80. Would help if I write it right. Circumference is 2 pi r. Remember, we're looking at half of that. All right, because the Superdome is not curved on the bottom, so we're looking at half of that. So we're looking at half of the circumference. So that's really just going to be half of 2 pi r, which gives us pi, which is 3.14. And our radius is going to be 680 divided by 2. which gives us, and my answer on the sheet I'm looking at, so we have 1,067.6 feet is their circumference. And I bet you haven't seen half of what I've been doing lately. I hope you have. If not, I've talked through the key. All right. How long would each shape have to be to cover the following hexagon? Now realize this is hexagon. 1, 2, 3, 4, 5, 6. 6 sides. Hexagon. If I want to break this into a isosceles triangle, I'm going to need 8. You can do it where the easiest way to do this is to print out the shape and then put isosceles triangles on top of it. Another way to do this would be to get a set of tanagrams and make this shape using the isosceles triangle. And believe it or not, even though I have tanagrams all over my house, I cannot find them right this minute. But it's 8 isosceles triangles would take to make this shape. How many isosceles trapezoids? Well, in each trapezoid, each isosceles trapezoid, there are 3 isosceles triangles, so it's going to be 8 divided by 3. Okay. A square is, remember we said it's 2 isosceles triangles, so it's going to be 8 divided by 2, so that's 4 squares. Parallelogram. In a parallelogram, there are 2 isosceles triangles, so it's going to be 4 parallelograms. Okay. Now I want to find the area of this airplane wing of a Boeing 747. Well, both of these are trapezoids. This is my base on 1, so this is B1, B2, and B2, and then this is going to be B3. So if I call this shape 1 and this shape 2, then the area of 1, so the area of a trap, is 1/2 the height times B1 plus B2. So the area of shape 1 is going to be 1/2 times 17.5 meters times 3.9 meters plus 8.7 meters. Now notice, again, it doesn't matter that this is isosceles. It doesn't matter that these 2 sides, that this is not isosceles, is what I'm trying to say. All it matters is that these are parallel. It's a trapezoid, right? And so then I get the area of shape 1 is 110.25 meters squared. And the area of shape 2, again, is a trapezoid, so that's 1/2 9.5 meters times 8.7 meters plus 14.2 meters, which gives us a shape of an area of 108.775 meters squared. So that gives us a total area. So that's A1 plus A2. So that gives us a total area of 219.025 meters squared. All right, that is going to end the lecture on 10.2. I will combine these 2 videos together. Please let me know if you have any questions, and I'm sorry this was so choppy and oopsied because my answers were not always correct on my sheet of paper that I was looking at. But thank you very much.